for an ideal gas, and there are two paths, right? In the PV diagram, this is T1, this is T2, isothermal path, and this is my first point. Go to this point A, come back to the point 2. I can go to by this path and come back to this point. This path is called 1B2 path and one is a 1A2 path. There are two paths, and you have to see that entropy change is independent of path because it's a property, entropy is a property, and that should be the state function. This first point and the function of the first point and second point, it should not be depending on the path you follow. So two reversal ways. One is constant volume process, 1A, where we have, you know, that du equals to dq minus dw, constant volume process equals to 0, is du equals to d. And du equals to, you know that's CVD, so dq is equals to du and dq CVDT. So you have delta S1A, which is from 1 to A path, and we know that dq reversible by t, which is 1 to A Cv dt by t, which is Cv ln t2 by t. Am I correct? Next is delta S A2 path. Is A to dq reversible by t. Okay, and for that path volume is changing, but temperature is constant. So that means du equals to 0. So dq equal to dw. Am I correct? For that path temperature is constant. So if temperature is constant, we have found the internal energy change will not be there, and in that case we have dw equals to dq, and dw is nothing but pdv, A to 2 pdv by t, and for ideal gas pv equals to RT. So p by t equals to R by b, R A to 2 dv by b, which is R ln b2 by ba, which is ba equals to b1. Same one. It should be b2 by ba and ba equals to b1 by same one, right? Yeah, because that's the x-axis. So your delta S will be total delta S for this path, which is Cv ln t2 by t1 plus R ln b2 by b1. Second process, which is delta S 1b, delta S b2. What is delta S 1b? I won't do the process, I think you can do it. Delta S 1b, how much it is? Delta S 1b, do you calculate? Delta S 1b, you do calculate? Yes or no? Cp ln t2 by t1, right? How do you get t2? Because B is there, no? B is there. So B is at another temperature T2 line, right? Okay. So delta S should be Cp ln T2 by T1. Delta S B2. You can say B temperature is T2, so you don't have any problem. But here we will see the real problem. Delta S B2, how much you got? Delta S B2 again, isothermal path. du equals to 0, dq equals to dw, dw equals to pdv. R ln B2 by BV. But this is not the acceptable answer because I know only these two steps, first and final steps. You should not know any, or result should not have any intermediate step property because you have to express the change in terms of the initial state and final state. Initial state is 1, final state is 2. Right? Initial state is 1, final state is 2. So you have to express it in terms of 2 and 1, not B. B should not come in picture. How to proceed further? V2 by VV, somehow can you write something in terms of 1 and 2? V2 by VV equals to? In terms of pressure, can you say anything? PV by P2? Am I correct? PV by P2 equals nothing but P1 by P2, yes. And this is nothing but, so this will come as minus R ln P2 by P1, am I correct? Yes or no? So you are getting this. They are not same, no? They are different. This CB, CB all are different. But you know the ideal gas CP minus CB equals to what? So you can have CB ln T21 plus R ln T21, and similarly that T2 and this P2, it will be combining together and you get P2 V1. Okay? Because we know that P1 V1 by T1 equals to P2 V2 by T2. If you substitute that, you get the same. Right? Okay, so this problem is clear, and that shows that entropy is a property and change in entropy is independent of for this ideal gas. It should be happening for real gas. You can take up any problem. Problem number 19, the first assignment. A rigid and insulated tank of 1.2 meter cube is divided into two equal compartments by a partition. One compartment contains an ideal gas at 400 Kelvin and 3 megapascal, while the second compartment contains the same gas at 600 Kelvin and 1 megapascal. The partition is punctured and the gases are allowed to mix. Determine the entropy change of the gas. The isobaric molar heat capacity of the gas is equal to 5 by 2 R kilojoule per mole per degree Kelvin. Let's start on. Punctured. Object could be circular mode, that's no problem. 600 degree Kelvin, 1 megapascal. This is 400 degree Kelvin, 3 megapascal. Equal compartment. Equal compartment. V equals to VV equals to 1 meter cube. NA equals to PA, VA, RTA. We have to know the number of moles in each compartment. Okay? PV equals to RT. Correct? So what is PA? What is, how to calculate how much it is? How much mole it is? How much is PA? How much is PA? 3 mega. Not 3 mega. 3 into 10 to the power 6 Pascal. If you put 3 here, you get wrong result. That's what I said. You know, 3 into 10 to the power 6 Pascal. VA equals to this Pascal, you know, Newton per meter square. You are okay. So unit is correct. So if you want, you can write anyway. This doesn't matter. So VA equals to 1 meter cube, right? RTA is R is 8.314 joule per mole per degree Kelvin. 400 degree Kelvin. This K and K will get cancelled. Okay. Then we have joule per mole. We have meter cube. How to get, what will be the final unit? How to get it out? Tell me, who can tell me the steps? This is the point you can actually learn how to, this Pascal. Newton per meter square, not per meter cube, sorry. Yeah. So you will get meter. Meter equal to joules. Okay? So this and this will go and you have how many moles? How much is that? 902.093 mole. 902.093 mole. NB you can calculate similarly. I want the final answer. NB you can calculate. I want the final answer. Pardon? 200.465 mole. Please tell me the units. Don't tell me the only numbers. 200.465 moles. And we can assume that no chemical reaction. We can assume there are no chemical reactions. Assume that there are no chemical reactions. So in that case, if you puncture, there will be no chemical. If there are chemical reactions, then the first law of thermodynamics will be changed and delta H, all those things will come in picture. Those things are not a simple problem. So first law of thermodynamics. First law of thermodynamics. It says delta U equals to Q minus W. Okay. And here total volume is same, it is Ni Cv delta T equals to no heat supply and no total volume change. Okay. So we have Na Cv T minus Ta plus Nb Cv T minus Tv equals to 0. And this, if you solve it, you get temperature. And then that's it. This kind of problem I think we have discussed earlier, and we can get from here temperature, then you can calculate the final pressure, which is P equals to nRT by V, which is Na plus Nv into RT by V, and some answer we get. Okay, and then you can calculate delta S1 and delta S2 for the first two gases. Delta Si equals to NiCp ln T2 by T1 minus NiR ln P2 by T1. Why this path? Because if you look at, you have what process you have actually undergone. So this is the process actually you got actually earlier. Isonormal path is there and constant, volume or constant pressure process. So any of the path we have got the expression earlier, and this I think we agree with. If once you do that, we can actually get individual entropy change for each compartment, first compartment, second compartment, and total delta S will be delta S1 plus delta S2. Right? You can solve it right at home. And total delta S will be, I want to know the answer maybe next class, but you can get the answer 2.19 kilojoule per K. Check it out, 2.19 kilojoule per K. So with that, I think I have done enough on the entropy change, reversible, irreversible process. And now the time is to combine first and second law of thermodynamics and proceed further. Combine first and second law of thermodynamics. Combine first and second law of thermodynamics. First law says delta U equals to Q minus W. If delta U is tending to 0, you can write differential sense du equals to dq minus dw. Differential sense from calculus. This is the first law. Second law talks about definition of entropy, which is ds dq reversible by t. If I don't put reversible, then you have to do entropy generation. We won't do it. This du path independent, so we can say du could be evaluated reversible path. So it could be dq. So you can say that this du can be dq reversible path minus dw reversible. No problem. What about the formula? This is pdv. Reversible path. Definitely it should be pdv. And this will be tds, right? So you got du equals to tds minus p dv. Combine first and second law of thermodynamics. This is the combined first and second law of thermodynamics. Du equal to tds minus p dv. Internal energy, you saw how to evaluate. But if I say, what are the independent variables? Sometimes we say function x, y. X and y independent variables, and with that function is changing, right? Okay? So far we have not thought about internal energy can be expressed as a function of some independent variables. The first time. Can I express u as xy? Function of xy. And what are x? What are y? What are? How? Why not t and p? Or t and b? I can say t and p. U is the function of t and p. Why s and b? Yeah. Let's see how we can defend your answer. I can say U is the function of t and p. Because t and p are also there. They are also changing, right? Temperature and pressure. It looks more fundamental. Why I am saying U is the function of s and b? Any answer? No answer. That means you told Arvind, on what basis you told madam? S and B, just I'm asking casually. That level. Okay. So the answer is not that particularly clear. Let's see. Why? Answer is correct. U is a function of S and B, but you have not got the proof. Let's see any full proof is there. Any function xy we write as df dou f dou x at constant y dx plus dou f dou y constant x dy. Correct? So we write du equals to tds minus pdv. That means if u is the function of, I'll say u hat sv, then you can write du as dou u dou s constant v ds plus dou u constant v dou u dou v constant s dv. By comparing equation 1 and 2, now we got interesting stuff, which is t equals to dou u by dou s at fixed b and minus p equals to dou u by dou v at fixed s. Correct? Yes or no? Yes. So you got many interesting things now. You got the t, which is dou u by dou s at fixed v, and minus p equals to dou u by dou v at fixed s. This u is the function of s and v. Okay? If I say it is a function of number of moles, if I I say this is a function of number of moles N for variable mass, U equals to U hat S V N. You can write this as du equals to dou U hat dou S V N ds plus dou U hat dou V S N dV plus dou U hat dou N S V dN. Basic principle of calculus. This is equal to P, this is equals to minus P, and this is equals to what is that? Chemical potential. Definition. So far we don't know the physical quantity called chemical potential. That's definition. So far it is okay. I have not come to the point where I can be saying that okay, chemical potential is something that you have to wait for some time. How to feel what is called chemical potential? You have to feel for any thermodynamic quantity, otherwise you won't learn. Okay. Quite often this U is called as homogeneous function. This is called as some term I am using called homogeneous function. Some term I am using called homogeneous function. What's the definition of homogeneous function? You have done BTech first year mathematics. What is called homogeneous function from calculus? Homogeneous function, calculus. F of x, this homogeneous function is a function. You are talking, I understand what you are talking. You are talking like some differential equation is homogeneous, inhomogeneous something, but it's not the thing. Homogeneous function is something different. Any of you have any idea? Okay, let me explain. Can you go to the Krejcik's book? Krejcik's book you have, right? Krejcik's Advanced Engineering Mathematics. You can learn more, or B.S. Grewal's Engineering Mathematics. If F is a homogeneous function of order k in x1, x2, xn, then f lambda x1, lambda x2, lambda xn can be written as lambda to the power k f of x1, x2, xn. In that case, the function f is called as kth order homogeneous function. I think you might have seen this, right, in calculus. You look at any of your notes of your BTech mathematics. So f is a homogeneous function of order k in x1 to xn. If f lambda x1, and lambda is a scalar quantity, any number. Lambda could be 2, 3, 5, 10, 15, whatever. There's some number. If lambda x1, lambda x2, lambda xn, and in that case we can write it is lambda to the power k if x1, x2, xn. If this property holds, then you can say this f is a homogeneous function. Now my question is, can this be called a homogeneous function? Can this be called, can internal energy be a homogeneous function? If it is, what's the order? First order, second order, third order, fourth order, 0th order, what's the order? Any idea? What's your guess? Any idea? Huh? But here when you define the homogeneous order, it is the order k. Here nth parameter, did I say is nth order homogeneous function? You see the property. I am actually putting increment each variable lambda, and I am taking out lambda to the power is there. These are original variables and depends on this to the power exponent. But any idea? That means what I am trying to say, u lambda s, lambda v, lambda n, lambda to the power k, u s v n. What is this k? And that will say the order of the homogeneous group. That will say order of the homogeneous function. We are seeing this for the first time in thermodynamics. Anybody who has taught this in thermodynamics? Okay, so that means you have entered the MTech level thermodynamics. BTech level is over. Okay. First of all, how to prove this and how to get the value of k. K should be a number. 0, 1, 2, 3, 4, 5, any number, is integer. What is that? How to get that number? How to prove it? Any clues before I proceed? How to attack this problem? Pardon? You don't know. What matrix? I cannot say any matrix here. I understand you are studying matrix in the mathematical methods course. That is not related with this. It is different. Thermodynamics is fully based on calculus. Matrix will not come here. No vector space here. Fully based on calculus and mostly we will be doing integration by parts. Somebody asked me what is the application of integration by parts. Why we do that? We will show here how to apply integration by parts and how often you can use it in thermodynamics course. So no idea. So we will be introducing the concept of specific variable. Advantage of specific variable, it does not change with molecules, number of mass, right? It does not change with number of mass. Extensive variable per unit mass is a specific variable, not intensive but specific variable. The specific variable, intensive variable, they behave the same way. Intensive variable is fundamental, the specific variable is not fundamental because extensive variable is fundamental. The extensive variable per unit mass is a specific variable, right? Extensive variable per unit mass is a specific variable. Okay. So V equals to capital V by N, S equals to capital S by N, U equals to U by N.
So what is the difference between specific property and specific variable?
Same. Temperature is intensive property, intensive variable. Okay? Because volume is a thermodynamic property, entropy is a thermodynamic property, internal is a thermodynamic property, they are also variable. Okay? Temperature is a variable, temperature is a property. Okay? It's so obvious. The specific variables are, we cannot write the same way temperature. Temperature is already intensive variable. Intensive variable, don't try to divide by mass because already it is intensive. It does not depend on mass. This is a common mistake, people do it. Okay. So when you have U, S, V, N, what will be the corresponding U from here in terms of the specific variable? If U is the function of S, V, N, what will be small u? Function of small, comma, and small n. Because I am saying it is a function of, it should not be depending on number of molecules. Otherwise no point to divide. So E is the only function of S and V. So you writing as U is the function of S, V, N, it will be converted to U is the function of S, V. Okay? So you say that U equals to U hat SB. And interestingly, if U is the function of U hat SB, capital U is what? N into U. Based on the definition. We can write this as N U hat SB. Right? And you can write this as U hat S by N, V by N. Okay? And that should be confirming that it is nothing but U hat SBN. That means everything is correct. We are confirming. The function of entirety is function of SBN, which is U hat. Now, coming back to your left hand side. U, lambda S, lambda B, lambda N. If I want to write like this, what should I write? Like this. What was that? It is U, S, B, N. What should I write? Analogous way. Next step. Next step. First, next step. Just raise the hand. If you tell so much, then I'll be confused. If somebody wants to volunteer, please raise the hand. You can do mistake, no problem, acceptable. Please raise the hand. U equals to N into U. The function of SPN. Lambda S, lambda B, lambda N. What will be the two terms which will be multiplied? Please raise the hand. Yes, sir. Into lambda N into small u at S B. Am I correct? This SB is what? Lambda S by lambda N, lambda B by lambda N, following the same argument. Correct? So, I can cancel this. I am getting N U hat SB. And that is what? S by N, B by N. Sorry. By comparing that, you can write lambda U S B N. Am I correct? So, what is U then? Homogeneous function of order 1. So, internal energy, we have learned that from mathematics. Internal energy is a homogeneous function of first order. Internal energy is a homogeneous function of first order. Okay. We know du equals to TdS minus PdV. This is the combined first and second law of thermodynamics. We can also write this as TdS equals to du plus PdV and ds 1 by T du plus P by T dV. Sometimes this is also called as combined first and second law of thermodynamics. This is called as energy representation of the combined law. This is called as entropy representation of combined first and second law of thermodynamics. One is energy representation, another is entropy representation. Okay? And 1 by T should be equals to, who can volunteer? 1 by T should be equals to, raise the hand fast please. Yes sir. Huh? What? Beta? What is T? I think we are in Mars, not in Earth right now. T is what? What? Did I say D or do? Do you know, right? Partial. Don't expect that I will be teaching the difference between partial and ordinary derivative. I am teaching advanced method topology. If I do that, then I should leave the class, right? Which is dou U by dou S at fixed B for this case. If I put in that is that. What is that? 1 by T. That's what I am asking. First raise the hand and then tell. Any hands? What is 1 by T? It's so straightforward. I am not telling the answer. No answer. Nobody can tell? Yes. Yes, sir. What is that? Dou S. Please talk slowly but high pitch. Yes. Dou S by dou U. And then fixed. Yes. Can you tell what is P by T? What is P by T? What is the P by T? Any hands? Yes. Can you volunteer? No. Please try it out. Yes.
Dou B by dou B.
What is that?
Dou B by dou B.
Dou B by dou B.
Dou S by dou B. Dou S by dou B.
See, you didn't raise the hand. That's that thing I don't like that teacher. This is called cowardness. Please keep your mouth shut because I cannot teach here. It is not a fish market. The poor guy is trying his best. If you act smart, then you raise the hand. Don't be acting like a coward. Please, sir.
Dou U by dou B.
Not dou U. Is dou U? Is it why you are saying dou U? What is the function? Can you tell the function? You cannot tell the function. What is the function here? Can you tell that? UV. Now give me the answer. P by Q.
Dou U by dou
Again.
Yes.
Dou U by
P by T.
dou U again here.
Sorry. Dou S by dou B.
Dou S by dou B at constant.
At constant, S.
Okay, I think nobody understood the class. Nobody understood the class. Nobody understood this. I have to go back kindergarten level. So you have got ds equals to this. That means you can say that S should be function of U and B. If S is the function of U and B, I can write ds equals to dou S by dou U at fixed B du plus dou S by dou V at fixed U dV. If you compare, you can get the answer. It takes so much time, people are so much confused. You have to visualize, you don't have to mark anything here. And this with the entropy representation, you get set of functions, and those functions are called as massive function. Those functions are called as massive function. This is the original thing. From here, we can get Gibbs energy, Helmholtz energy, enthalpy, everything. From here, you will get similar kind of thing. I will show you that from here, what you are getting from here, you may expect something in the exam, but whatever functions you get from these entropy representations, they are called as massive function. They are called as massive function. Now, question is, we have found dou S by dou V, dou U by dou S at fixed V, correct? That's what we have found. Because du equals to Tds minus Pdv. Can we write, I am putting a question mark, dou U by dou S at fixed V? Let me put that. I have been given minus P, dou U, dou V at fixed S. From this, can one write du equals to TdS minus PdV? If du equals to T capital S minus PD capital V, can one write d small u equal to TdS minus PdV? That means this has to be equals, and can you write? How can you prove it? If you can prove it, then you can write. Because u is the function of SV, does not mean that you can write this. You can say du equals to dou u hat dou S V ds plus dou u hat dou V S dV. This much you can write. But who told you it is T? From first law of thermodynamics you got du equal to TdS minus PdV. That has been proved. Who told you this T? Who told you this minus P? Nobody told you. How to get it? This is the extensive variable representation. Extensive variable representation. This is the specific representation. Specific variable representation. My question is, once you say that this equals to this, then you can say T, then you can say minus P. Otherwise you cannot say. Up to this you can stop. What people do, they divide all n. They say we divide by n, then we are getting it. How can I do that? Some people, some student told me, so it is very easy. du equals to TdS minus PdV. Guy comes and tells, sir, d small u TdS d small v. Is that correct? Yes or no? Yes? Why not yes? Why not no? Or why yes? Why no? Why you cannot say that? What? Yeah. It has two terms. It has two terms, right? Differential of u by v. V du minus u dv by v square. Okay? You cannot write just like that. But it is correct. I try to prove it. This is equals to this. How to prove it? How to prove it? Dou u hat dou S, most generalized Vn. If you have TdS minus q dv plus nu dn, this would be Vn. I am putting more generalized. That means if it is done for the open system, the variable mass, so the first law, you can write like this. I want to prove dou u at dou S at small v. How to prove it? So start from here. Dou u hat dou S Vn, which is, you can write dou capital S n u hat Vn. This n u hat is function of SV. We have already done it. U can be expressed as n into u, correct? ddx of uv, multiplication, u dv dx plus v du dx, calculus, which is n dou u at dou s, dou capital S by dou small s. N is constant. Okay, if n is constant, n is going out. This is constant, right? N is constant, n is going out. So we have Vn. Is this step clear to all of you? Yes or no? Yes? Why I am not taking two product? Because my n is constant. Since n is constant, I can take n out. Only one term is there. Now, this is the function of two terms, S and V. The function of two terms. From calculus, it says that since V is constant, my S is changing. So this dou u at dou S by dou S, the chain rule of differentiation. The chain rule of differentiation.